So now that we've come up with our formula for the derivative of an inverse function, I wanted to talk about how to actually use it. If you're interested in finding the derivative of an inverse function evaluated at some value x, then knowledge of the original function is going to be key to your success. So I'm going to refer to f inverse as our inverse function and f as our original function, as it were. So in order to create this expression right here, in order, we would need to determine the original function, which is typically done using techniques of algebra as far as finding inverse functions is concerned. We would need to differentiate that function, so I guess in order we're finding f, then we'd be finding f prime. We would then plug in the inverse function, which would be f prime of f inverse of x, and then finally take the reciprocal. Now, I wanted to demonstrate this technique with what is hopefully a fairly straightforward function. When we introduce the power rule, the inverse of a power would simply be a root. So what I'm going to do is consider a root. Let's say that f inverse of x is equal to, let's do a fourth root of x. Now, if we're dealing with a fourth root, that means that the original function would have been x raised to the fourth power. Now, if we follow the four-step process that we saw above, this would be step 1, where we actually figure out the original function. Step 2 would be differentiate the function. So f prime of x would be equal to 4 times x raised to the third power, according to our power rule. Step 3 of the process would be go ahead and plug in the original function, and we'll get f prime of f inverse of x. This would be 4 times our input cubed. That would be the fourth root of x. And then finally, the derivative of f inverse of x would be the reciprocal of what we see here. This would be 1 over 4 times the fourth root of x quantity cubed. Now, it should be pointed out, though, that if we were to express this fourth root of x as x to the 1/4 power, then we would be dealing with 1 over 4 times x raised to the 3/4 power. Whereas if we had taken a look at the original function and simply expressed it as x raised to the 1/4 power and then differentiated using that power rule, we would have arrived at the same result, 1/4 times x to the negative 3/4 power. So one thing that the derivative of an inverse function does is it validates that you are allowed to take the derivative of any power, regardless of whether it's a fraction, a negative number, irrational, doesn't really matter. The power rule works for any power.